We're so often treated like we're just one data point in some giant average. But what if I told you that relying on those averages isn't just a little misleading? It can be downright dangerous. So let's dig into why the average person is a complete myth and why getting your head around that could honestly change everything.
All right, let's start with a choice. I want you to put yourself in someone else's shoes for a second. Imagine you're a teacher and a new student is about to join your class. The very first assumption you make about her could set the course for her entire life. So, what do you assume?
This is Kim. Her file says her IQ is 40. She experiences seizures, her motor skills are uncoordinated, and she doesn't use words to communicate. Now, based on this data alone, a certain picture starts to form in your mind, right? But is it the right one? That first assumption you make, well, it creates one of two totally different realities. If you assume she's incompetent, you'll probably focus on just basic life skills. You'll separate her from her peers. But what if you assume she's competent? Then you teach her to read, you include her in regular classes, and you help her build real, meaningful relationships. The path you pick isn't just about what she learns, it's about the kind of life she's even allowed to have. Now, I know this might feel like just a hypothetical story about one student. But what if this exact same thinking error, making these huge judgments about an individual based on group data or a single number, what if that's happening all around us, shaping our entire world? Well, there's actually a formal name for this mistake. It's called the ecological fallacy. It's the logical trap we fall into when we think that whatever is true for the group average must be true for every single person in that group. And man, it is a trap we fall into all the time. Seriously, just think about it. We design our entire education system, our workplaces, even the products we buy for the average person. But as more and more researchers are finding out, this average person is a myth, a total statistical ghost. No one is perfectly average in every single way. Okay, here's where you can really see this fallacy in action. You look at this chart, and at first glance, things look great. The classroom average shot up by 15%. Awesome, right? But wait, look closer. That average is basically a lie. It's being pulled way up by a few superstar students, while most of the individual students in that class are actually doing worse. And that's the danger. The group trend can be the exact opposite of what's happening to the individuals. Let's push this idea even further with a bit of a paradox. Is it possible that, on average, studying more could be linked to lower test scores? The answer is, kind of weirdly, yes. But for any one student, for you, studying more almost always leads to better scores. So how can both of those things be true at the same time? This is something called Simpson's paradox. It's what happens when some hidden variable, some lurking factor, completely reverses a trend when you combine different groups of data. So for example, imagine a university where, overall, it looks like men get admitted at a higher rate. But when you break it down by department, you find that women actually get admitted at a higher rate in every single department. How is that possible? Well, it turns out the women were applying to the tougher, more competitive departments. The hidden factor, how hard the department was to get into, flipped the whole conclusion on its head. And listen, this is not just some fun brain teaser for stats nerds. This very same logical error has real life or death consequences in medicine, especially in how we test and approve new drugs. You see, in drug trials, it can take a really long time to know if a new medicine actually helps people live longer or feel better. So researchers often use a shortcut. It's called a surrogate endpoint. It's some biological marker, like whether a tumor is shrinking, that's supposed to be a stand-in, a proxy, for a real outcome. But here's the huge problem. We just assume that the proxy works for the individual. Sure, a drug might shrink a tumor, and that shows up in the data. But does that really, truly translate to a longer, better life for the actual patient? A lot of the time, the evidence for that connection is surprisingly weak. It creates this massive uncertainty because we're just assuming a link that might not even be there, especially when it comes to something as important as quality of life. And this gets right to the heart of it. A correlation that you see in a big group doesn't automatically mean it's causing the effect for an individual. Just because tumor size and survival are linked on average doesn't mean shrinking one person's tumor is what's going to save their life. As a couple of researchers famously put it, a correlate does not a surrogate make. So you can see the pattern, right? In education with Kim, in data with Simpson's paradox, and in medicine with these surrogate endpoints, it's the same fundamental error, just wearing a different disguise each time. So the big question is, How do we train ourselves to spot this and, stop doing it?
The solution starts with an idea called meta-theory. Now that sounds super academic and complicated, but I promise it's not. It's simply a theory about another theory. It's the practice of stepping back and really looking at the assumptions behind the models we use to make sense of the world. It's thinking critically about the way we think. A really powerful example of this in action is meta-science. It's sometimes called research on research. How cool is that? Meta-scientists actually use the scientific method to study science itself. They're looking for flaws, biases, and bad habits so we can make the whole system better. It's literally thinking critically about our thinking.
So this whole meta-theory approach gives us a simple 3-step framework. Step 1, analyze the underlying theory. So the idea that group data can predict what will happen to an individual. Step 2, question the methods. Are we actually measuring what matters here, or are we just measuring a convenient proxy? And step 3, improve the practice. Shift our focus away from averages and on to individuals, especially when the stakes are high. And that brings us all the way back to where we started, back from the big, abstract world of meta-theory to the very real world of a 16-year-old girl waiting for her teacher to make a choice. This all leads us to a really powerful guiding principle, the least dangerous assumption. It's simple. It says that when we don't have all the facts, our choice should be guided by one question. Which of my assumptions, if I turn out to be wrong, will do the least amount of harm? For Kim, this means we absolutely must presume she is competent. Why? Because human intelligence is way too complex to be boiled down to one single flawed number. Because all the research shows us that people learn best when we hold them to high expectations. And most importantly, because the damage from wrongly assuming someone is incompetent, denying them an education, friendships, a future, that harm is massive and you can't take it back. If we assume competence and we're wrong, well, the consequences are so much smaller. It just means we tried too hard. In the end, it really all comes down to this. The average is a useful tool, but it's a myth when you try to apply it to a single person. The proxy is a tempting shortcut, but it can be a total fantasy. The one tool that is never a fantasy, though, is the discipline to always ask the least dangerous question: what assumptions am I making right now, and what's the cost to another human being if I'm wrong?